All right, welcome everyone. My name is Tony Hallam and I'm going to be your instructor for this series of workshops on HPC Carpentry today and tomorrow. This course is being run by EPCC, which is a supercomputing and essentially computing group out of the University of Edinburgh. I'm actually an applications consultant for EPCC, and my day-to-day job is essentially to help people to use or make the most of the resources that we have at EPCC. A couple of admin things before we get started today. I hope everyone has been able to follow the setup instructions that were emailed out to you, particularly getting a safe account and adding an SSH key to your login information within Safe. If you haven't done that just yet, don't worry, we're going to run through a little bit of that as we go through the day, but you'll need to, essentially to have that set up to get access to ARCHER2 and follow along with any of the exercises that we're going to do. I am giving this course for the first time. My background is geophysics, although I've spent quite a lot of time around computers and HPC. So hopefully we can work through this course together and get as much out of it as we can. Today we're going to be focusing on essentially the command line, or the shell as it's known, working out how to log into the HPC system and how to navigate and look at things and edit files. By the end of the day, hopefully you'll feel more comfortable with the concept of working within the shell and understand some of the things that you can do and the way that it kind of liberates you to automate and run things more simply in a HPC world. I'd encourage you, if you have questions, please use the Blackboard interface, raise your hand, ask questions in the chat. I'll be keeping an eye on the chat session and trying to answer questions as we go. I think for everyone, we'll get the most out of this if you can be as interactive as possible. If things aren't explained well, please let me know and we'll go back and rehash things. The process today is, let me share this window. So all the content for today is available online through this website. I'm just going to post this in the chat here, but you will have received this link before from the joining instructions. Ideally, you will have been through the setup already prior to this session, but if not, we'll try and help you through as we go. We're starting now, hopefully finishing around 4 o'clock, and we have a break at 20 to 11, lunch for a couple of hours at 12, and then another break in the afternoon. These sessions are a bit of a guide, so any questions or discussions that you want to have, feel free to ask those questions, and I'll do my best to answer them. We also have a couple of offsiders available during the session. So if you have questions, I may move you into a separate breakout room where you can work through those problems with a moderator without disrupting the class too much. I wanted to start the session with a little bit of a poll, if that's possible. Hold on a second. Let me just mute. So we're going to start with a poll, just so I can kind of get a feel for where we're at in terms of the OSs that you're using. So this will just give me a bit of an idea of where most of you are coming from. So if you could respond to those polls for me, that would be great. Now, for reference, I'm going to be using Windows 10 for the 2 sessions today and tomorrow. Okay, looks like most people are using Windows 10 or Mac, which is good. Okay. All right, you might move on. That gives me a rough idea. No one's using Linux then. Okay. The other question I want to ask you is, have you been able to log into Archer? Yes. All right, I'll just leave that there, and I think we'll kind of kick on with the session. So, big questions. Why use Hpc? I think the main reason people talk about using high-performance computing or HPC is that often they have a problem that doesn't necessarily fit on their local laptop or desktop anymore. So you may want to perform a simulation a large number of times. And if you were to run that serially on your laptop, it would take many days or weeks or even years. Another problem that is common is you have too much data, and you can't fit that data reasonably into memory or even onto storage. So your hard disk, for example, is not big enough for the amount of data that you have. And that's a reasonably common problem. And then the last type of problem is you want to run computations which are just so complex. Your model is so difficult to run and so demanding of your computer that if you were to run it on your local machine, you basically would be waiting for an infinite amount of time for it to finish. And often that is common in situations like computational fluid dynamics, for example, where people are modeling airflow or water flow around objects, or sort of fluid flow simulations, for example, like I've been exposed to in the past. So in all of those cases, essentially the only way to kind of overcome that problem is to upscale. So we need to provide more computing resources to the software that we're trying to run, so that software can run either faster or can run with more memory available, or can have access to the storage that it needs. There's a few different bits of terminology that are related to the idea of HPC, and that's sometimes called clusters or supercomputers or high performance computing. But essentially all of these refer to this idea of upscaling. And we want essentially to make either better computers or many computers available to people who want to run these problems. Why do we have these big kind of shared resources? Well, often it's not efficient or cost effective for individuals or small research groups to buy the computer that they need to solve their problem just for, you know, the few days or weeks or months that they're actually running the computation. It's also not feasible for individuals or small research groups to spend the millions of dollars required to actually buy, maintain, and operate the equipment. So these shared clusters, or these HPC resources, or supercomputers as they're called, are essentially there to provide a pooled resource that everyone can use and share to solve their problems faster, or to solve bigger problems, or to solve them more efficiently or more cost effectively. So all of these things are good reasons why you might want to use HPC. So moving along, one of the things that's a little bit daunting about HPC, and the reason why we're kind of running this workshop today, is that HPC resources aren't like the resources that you have at your disposal on your laptop. They're not permanently allocated to you, and they don't always, they're not always made available via a desktop interface. In fact, they're rarely made available via a desktop interface. And as a result, you have to interact with HPC clusters or supercomputers using the command line. So the command line in Windows is often called like the command prompt, or another version of it is called PowerShell. And on Linux, it's often called the shell or the terminal. So the idea of the command line is that it's basically a simple program that runs in what we call a read, evaluate, print loop. So it will prompt the user for some input. It will read whatever input that the user puts in. It will then evaluate that input. So it will take that input away and try and execute it. It then prints a result and loops back to the beginning. So it will then prompt the user for another input. And if you've used programs like MATLAB or Python's interactive terminal or R, you'll be quite familiar with this kind of paradigm where the program has a language, a syntax. You put in a command, it reads the command, it runs some process in the background, it gives you a result, and then it asks you for another prompt. And that's essentially what it is, but for the operating system rather than for a specific programming language. The idea of this kind of command line interface to the computer basically goes back to the early days of computing, when people used to basically have like line cards that they would put into systems. The system would read the card, and then it would spit out a result, and then you would take that result and go and write another line card and do the same thing again. It's a little bit more sophisticated now. You have a whole heap of programs that you can run from within the shell, and you have different types of functionality, which we're going to cover during the course of today, that allow you to kind of manage the system, including things like folders and files, and to do text editing and so forth. So all of that is kind of available to you through the shell. The reason there is no desktop session with supercomputers is because it's just not necessary and not really appropriate for the situation or the paradigm within which supercomputers run. the general process for accessing Supercomputer is you will log in through a terminal, you will load all your data and information to that Supercomputer through the terminal, and then you will request that your jobs be run through the terminal, and they will go away, be run in a headless state, that is without a desktop, and then the results will be given back to you. So hopefully, if you've written sort of scripts before, like Python scripts, anything that basically creates an output just through some form of execution, then that is more or less the process with HPC. Archer runs Linux. In fact, most HPC systems will run Linux. I'm not sure if I know of any that run Windows. And the shell that ARCHER2 uses by default is called Bash, which is the born-again shell. Bash is widely available on many Unix systems, and it's been around for a long time. It is the shell that we're going to be learning today, but you should be aware that there are other types of Unix shell that you might encounter, such as C shell, T shell, and X shell, for example. And all of these have slightly different syntaxes that you may have to learn. But they essentially work in much the same way. You interact with it by entering a command that is executed, that returns a result, and then the shell works for a new command. Are there any questions so far when it comes to the shell? Okay. All right. Well, we might kind of move on then because there's quite a lot of content to cover today. But again, remember, if you have any questions, quite happy to take raised hands during the discussion. Happy to be guided by your understanding of where we're at and what we need to do. All right, so this one hopefully won't take too long, but essentially we need to have everyone connected to ARCHER2 so they can follow along with the tutorials and the workshop later on today. Cool. Okay, so you should all be able to see my terminal here for Windows. This is actually a PowerShell terminal. You can start either the command prompt in Windows or PowerShell by going to the Start menu and typing in either CMD or just PowerShell, and you should be able to find a shortcut to either or. In Linux, I believe, sorry, no one's using Linux, are you? In Mac, I think, I'm not super familiar with Mac, but I believe if you bring up Finder and type in terminal, you should be able to get a command prompt similar to this. Just a little bit about the anatomy of prompts. This one, for example, has some interesting information. Not every prompt will look the same, and you can customize them. For example, if you start the normal command prompt, you'll get sort of something like this, where you have a line telling you the current folder that you're in, and then just a prompt where you can enter any kind of text or commands that you want. For example, in the command prompt for Windows, if we wanted to just see a list of folders, we would type there. I prefer the PowerShell, which is sort of a successor to the command prompt, so I'm going to be working from there. The first thing that you need to make sure is that you have access to SSH. So SSH is essentially a program which allows you to log into other computers, and it does so by creating a secure tunnel between your shell and the computer that you're trying to connect to. The computer that you're trying to connect to needs to be running an SSH server so that it can accept incoming requests from your SSH client. So remember that as the person on who's trying to connect, you'll be using the client to connect to the SSH server. SSH is widely used, and fortunately with Windows 10, it comes with Windows 10 by default, I think. So in the PowerShell, for example, if you type SSH and use tab, you can tab through some of the different SSH commands that are available. If you're on Mac OS X, you will have SSH available, but you won't see the .exe extensions when you're tabbing through any of these. Has everyone been able to, let me create another poll here. I just want to know if everyone's been able to create an SSH key. So this would be using the SSH keygen command, which, following along from the connecting episode of today's workshop, would look something like this. Okay, still waiting on 16 responses. If everyone could respond to the poll. Okay. So I'm just going to create a dummy key here so that we can see what these look like. Usually we put them into this folder called .ssh, and this tilde here means that it's basically going to go into our home folder. So .ssh is kind of the config area for where we store these things, and you'll have a private public key pair created when you do this that essentially allow you to perform a secure authentication process when you connect to the SSH server you're trying to connect to. I'm just going to call this one test so we can have a look at it, but we're not actually going to use this. They will ask for a passphrase. So this allows you to authenticate the key pair. So if your key pair is stolen, someone still needs to know. Oh, why is that not available? Probably because this is Windows. So if your keys are stored as files on your computer, and a passphrase is important because if those files are stolen for some reason, then you will need to essentially have an additional level of protection. So the passphrase allows you to have an additional level of protection on your authentication keys, because these keys that you share between the server and the private one that you keep for yourself allows the server to be sure that it is you who is logging in. So if we go into that SSH folder, you can see that we created 2 files, both of which are SSH key pairs. The .pub extension is the public one. This is the one that you should be sharing with the server, and the one without an extension is the private one. We can have a look inside the public one, and you can see that essentially it just creates an ID which tells it what the encryption is, and then a string of different characters which we call a hash, and our login information, or where it was created. And this essentially is the information that we would provide to ARCHER2 so that they can then authenticate that it is us who is logging in. SSH has a large number of encryption options. So as you'll know, there are different types of algorithms which essentially encrypt the connection, or sorry, the passphrase that SSH uses in different types of hashes. So this hash here is an encryption of the key that SSH is going to use to authenticate that it is you connecting to the server. And the encryption algorithm that's being used in this case is ED25519. There are a number of other, no, there may not be, oh yeah, here we go. So for example, you have like DSA, ECDSA, or RSA. I think Archer recommends either this ED25519 or RSA encryption. So those encryption protocols are kind of dependent upon the system that you're connecting to. They might specify that only one or a couple could be used. But in this case, either of those 2 is fine for Archer. A couple of other things when it comes to generating keygen pairs. So we sort of talked about -T here being the encryption option. When it asks you for a password, it's really important that you have a strong password in this case. Now, I know everyone's kind of done their cybersecurity training, and being digitally aware, we're all kind of familiar with the concept of creating strong passwords which are either long and or a combination of different characters and numbers and symbols. That's really important because if you have a short password or an easy password to remember, it doesn't matter how good the SSH encryption is, someone will be able to brute attack your SSH key. So ideally, choose a password that is strong. Okay. So the second part of this process is that public key, the one that we created. So, for example, if you followed the instructions on ARCHER2's setup page, you might have created something that looked like this one. If you followed the instructions in the connecting episode of the lesson, you might have created one with the ED25519 encryption. Both are okay, but those then have to be added to your safe account. So I might just ask a quick question here in the polls. You added your public key, so remember that's the one with the .pub extension, to your safe account. Okay, so safe.epcc.ed.act is the website. You will have had a login here, and if you go to where is it? You'll have your username here at ARCHER2. You have this ability to add credential here, and then you can choose SSH public key, next, and then you can either paste the contents of the file or just choose file here. Navigate to where your SSH keys are stored. Select the one that you just created with the .pub. Add that, and you should be good to go. Cool. All right, so hopefully you have all managed to do that. The next step is basically connecting to Archer. So you've got your safe account, you've added your public SSH key after creating an SSH key pair specifically for ARCHER2 using SSH keygen on the command line and a strong password. You then, let's share the terminal. You then have to log into ARCHER2 using SSH and by specifying the private part of the key that you gave basically the safe. So in this instance, if I've stored all my keys in .ssh, so -I option here allows us to specify a specific key, and I need to specify the path to that key file. In this case, for me, it's the RSA ARCHER2 key. Okay, if you need help registering, Juan will step in and help you while we continue with the session. So you then specify the key file, right? So we've done that using the -I. You then need to specify your username. So for me, that's Hallam, but for everyone else, it'll be whatever your login account for ARCHER2 was. That will be your username. And then you give the login server for ARCHER2, which is just login.archer2.act.act. You're then going to be prompted for 2 passwords. the first password or the passphrase is the one for your key. So when you created your key using SSH keygen and you put in that password, then you need to put that key back in again. You'll then get a prompt for password. Now this is your ARCHER2 password, which is different to your SSH keygen password. The first time you get access to ARCHER2, you'll be given a temporary password, so you can use that. And immediately after logging in, ARCHER2 will prompt you to change your password to something else. So with those two passwords, you should essentially get access to ARCHER2, and it'll pop up with a prompt like this, kind of telling you that you've logged in. It'll tell you which landing node you've ended up on. We'll talk about what that means soon. And it tells you a little bit about that landing node machine, and it gives you a new prompt. So my prompt, again, might look a little bit different to yours, but you should see something that says your username at a landing node, and then possibly a full path description before what you can put in. Cool. And that is more or less logging into ARCHER2. There's a couple of final things probably to be aware about. The first is that you can exit your login to ARCHER2 at any time just by typing the exit command. And this will drop you back to the local shell. If you want to reconnect, good tip here is that in the shell, if you push the up arrow, you can get previous commands, if you didn't know that. So if you push the up arrow, you can get the previous command and you can log back in. So exit is how you get out of ARCHER2 if you need to. If you close the terminal, it will also exit you from ARCHER2, so that when you open a new terminal, for example, just opening a new terminal here, you'll be in the local shell again. You can often tell which machine your terminal is on, because sometimes when you're working, you might end up in a situation where you don't have an ARCHER2 prompt right at the top to tell you. Is you can look at the host name that you're on, and also the characteristics of the shell prompt. So in this case, we can see that this is the way the shell prompt looks for me on ARCHER2. Remember that the prompt for ARCHER2 is now not going to be the same as your local prompt. So we talked about this being a bash shell. So this is going to be slightly different from the PowerShell. Indeed, if I type in SSH here, you can see that we no longer have the .exes that we saw when we were working on the Windows version. How do we get to the shell from the login window? Do you want to, expand a little bit on that question, Liliana? Are you talking about how do we start the shell or the command prompt? Hold on. I think you should be able to Yeah, no response. Okay. Okay, logged into Archer. So when you log into Archer, if I just exit out of Archer again here, this is ARCHER2 shell. So essentially when you SSH into Archer, it drops you into a terminal or shell session on ARCHER2 itself. So you don't have to do anything after logging in essentially to have the shell active. It is automatically active for you. In fact, SSH is just creating a secure link to a shell session on ARCHER2 when you log in. So the shell is essentially already there. It's not. You can think of this as being like a direct link between your shell and running the shell on ARCHER2, kind of bypassing any notion of kind of logging in to a desktop or logging into a website, for example. It takes you directly to the point where you can start to query the computer, run commands, and look around. So this session was meant to take us through till 20 to 11. It's pretty important that everyone has been able to log in for the next stage. So if anyone's still having trouble logging into ARCHER2, if they could please drop a question into the chat, we'll try and help you out. If you have any questions now about the login process or how to get access to ARCHER2, please ask, and we might reconvene in, say, 30 minutes, so 10 to 11. Everyone can have a bit of a break. Have a look around in the ARCHER2 shell if you're familiar with Bash at all, and we'll get started on the next part of the session. Okay, so there's been a couple of questions here about the differences between a few loosely related terms such as Ubuntu, MobaXterm, Pwd, and PowerShell. Essentially, they're loosely related, but not the same thing. So Ubuntu, for example, is a Linux distribution. So if you were running Linux on your laptop, then one of the versions of Linux, kind of like maybe like running Windows 10 or Windows 7, is you could run Ubuntu, but it's more diverse than that. It's kind of like you know, you can get chocolates covered in sugar like M&Ms or Smarties, and they both do the same thing, but they're different. So Ubuntu would be like Smarties, and then another version of Linux like Red Hat Linux would be like M&Ms. So all of the versions or the distributions of Linux as they're known come in different versions. So Ubuntu is related to Linux. MobaXterm is a program you can download onto Windows, and it basically improves the or it filled a gap that existed where people needed to connect to Linux servers using SSH from Windows. It has some nice features, like it allows you to see the file tree in a kind of GUI example. It will save some of your login information, so you don't have to enter things all the time. I wasn't going to cover the setup of MobaXterm here, but potentially that's something we could look at in the lunchtime if you want to use that. Prior to Windows 10, SSH wasn't available explicitly on Windows. So to access servers running an SSH server, you needed to basically install a program that would run SSH on your computer. And MobaXterm and Putty were the two big ones I think that people were using for that. So they're essentially substitutes for SSH on Windows. PowerShell is essentially another version of the command prompt on Windows. So going back to the original versions of Windows like DOS and Windows 3.1 and every iteration that has come since, you essentially had access to the operating system via command prompt. In the 90s, a developer at Windows wasn't happy with the performance or the functionality that was available within command prompt, so he created an alternative terminal or an alternative shell that could do what he needed, called PowerShell. So PowerShell is essentially an alternative to the command prompt. Now the thing with PowerShell and command prompt now so this is, for example, command prompt, and if you start a vanilla PowerShell, it'll probably look something like this. They're more or less the same, but they have different types of functionality, different commands, different ways of doing the same sorts of things. PowerShell and command prompt can essentially be interchanged. So I think I should be able to access SSH. Yeah, so SSH is here in the command prompt as well. So I can essentially log into ARCHER2. Using command prompt as well, and this will, what is it? Log in ARCHER2. Sorry, I can't remember what the login is here. Okay. So this will essentially give you the same as what you had with the PowerShell. So you can use PowerShell or command prompt interchangeably. They'll do the same things in terms of giving you access to SSH, so you can log into ARCHER2. Cool. Was there any part of that? So to log out of ARCHER2, you just type exit in the ARCHER2 command prompt, and that will close the connection. Angie, so just thought it might be easier to show you rather than type it out in chat. Hopefully you're still listening. Essentially, when you're in the command prompt and you type in the SSH command, what I assume you're doing at the moment is you're just doing something like this. Where you specify your username and the server you want to log into. and it's just going to give you permission denied because you're trying to use a public key essentially. So it doesn't understand the key that your SSH is trying to use to connect. Because we created a specific key for ARCHER2, you actually need to tell SSH which key to use. So to do that, you give it this -I flag, and then you point it at the SSH key file. So for me, for example, that's in this folder .ssh, and the key file is called ARCHER2. That's not ID RSA ARCHER2. I think that's my key file. And then you give it the login. So it should hopefully. Is it the wrong key file? Hold on. No. It's just ripping the into this. We'll try again here. So I give it the key file and then the logins. And then it'll prompt me for the appropriate passwords. So that key file is the private part of the key file without the .pub extension that you created for the upload to the safe. Okay, there was some questions about MobaXterm. It's not explicitly in this course, but I thought I might share a quick view of the setup here. Hopefully I can get this working. Okay, so if you go to the MobaXterm website, you can download like a free home edition or portable version. That's what I've done here. And essentially, when you start it, you get something like this. And you need to essentially create a session. So we're just going to do the session. And you can go to SSH, which is what we're using. The remote host is the address, web address of ARCHER2. Username is the one that you have. Leave the port alone. And then you need to specify some advanced settings. So we need to specify the private key. So you come down here to use private key, and then you go to where your private keys are stored. So for me, that's in the .ssh folder of my personal directory. And then I specify the private key file that I'm using. And that should be all that it needs to do. And you hit OK. Fingers crossed this works. Nope. Not quite. Something not quite right. Okay. I've got the settings right here. So we close that. edit these settings. Log into dot. Oh, sorry, login2, that's why. Login.archer2. Okay, let's try that again. All right, so then it's just gonna prompt you for those two passwords. I'm not gonna save it, but it will log in and this will give you a session. And this is essentially just putting whatever we had in the shell into this window here, but gives you some nice tabs so you can move around. One of the nice things about MobaXterm, let me just edit here, is if we have this SSH browser enabled. I'm just going to close these two here. Log in again. Is it will show you the contents of the folder that your terminal is currently at. So this is kind of like a little file browser here on the side. So if I list the folders in this term, sorry, the contents of the current location of the terminal, you can see that this matches up to over here. And if I go into documents, you can see that that's empty. We'll sort of talk about some of these commands as we go, but this is sort of MobaXterm, and it's an alternative to using the command prompt or the PowerShell directly. More or less does the same thing, has a couple of extra nice features, and saves a few of your settings so that you don't have to type them in all the time. Okay, everyone. Hopefully you've had a good break. There's been a few discussions in the last half an hour. We had a bit of a discussion about the differences between Ubuntu, MobaXterm, Pwd, and the PowerShell. If you missed that, this session is being recorded and will be made available after the workshop is completed, so you'll be able to go back and visit that. I also demonstrated how to set up MobaXterm. That's not explicitly covered as part of this workshop, but that was also recorded. So if you prefer to use the MobaXterm GUI on Windows for accessing the supercomputer, that's also an option. I did want to cover one last thing. Khalil, you'll need to specify the SSH private key. So that's done using the -i flag like this, where this file here is the private part of the key that you generated for ARCHER2 before logging on. So I think there might be a bit of confusion if you're looking at the web page, because it does have, let me just blow this up, it does have this here, but this is only if SSH keys have not been enabled. So ARCHER2 requires keys, so you'll need to follow this process here. So there was just one last thing I wanted to cover in the setup of SSH, which I think might be useful for a few people. And that is that you can specify some of the options that you pass to SSH in a configuration file, so you don't have to type them in all the time. So depending on the system that you're on, usually if you go to your user directory, so on Windows that's just C users and then your user, and then you'll have a folder called .ssh, and in there you can create a file called config with no extensions. So you just kind of right click and then you create new text document and create a config file. To get rid of the extensions, you'll need to come up to view and turn on file name extensions here. That allows you to see the extensions of these files. If you haven't done that, I highly recommend doing that on Windows. It makes things much simpler. And within these config files, if you edit that config file with a text editor, you can specify some persistent details for a particular host. So a host is another name for a machine that we want to connect to. Our machine in this case is called ARCHER2. This is just a name, an alias that we want to give it. So this will be what SSH looks for whenever you reference the word, the name ARCHER2. And then you can specify some of those details that we were passing at the command line. So these spaces here are important because that's how it kind of differentiates between the different blocks of this configuration file. So the host name is just the login details. The user was my username. For that user, we can then specify an identity file. Remember, this tilde here just means the user folder. So this is pointing at my private configuration file. Don't worry about these two. The main thing is that you have this lot up here. What does that mean in the end? Well, when you go to log in using SSH, you can use that alias that you created. So that alias was the host alias we put here at the top of the file, ARCHER2. So we can just put SSH ARCHER2. It's actually going to go away to this config file and pull out this additional information so we don't have to enter it at the command line all the time. So that's quite a useful shortcut, so you don't have to remember all the information and all the flags that you have to put in for SSH each time. Cool. All right, let's kick on to the next part of the lesson, where we're going to be covering moving around and looking at things. Okay, just make this shell big. Okay, so hopefully everyone has been able to log in. Remember, we're using this command ssh-i with the identity file, the private part of the key, and then the login with your username and the ARCHER2 login server. What's going on? Oh. Sorry, it doesn't like this dot slash that it sometimes puts at the front here. For all logging in, to Archer, and we should all now have a prompt that looks something like this. Maybe not exactly like this, because you'll have your username and just the node name, potentially no colors. So let's get comfortable doing a few kind of basic tasks with the shell. And specifically in this 15-minute session, we're going to talk about moving around the file system and looking at things. So there's a large number of commands available to you in the Linux prompt, and you'll learn a lot of them as you go and as you get help and as you read things on the internet that tell you how to do things. But to begin with, we're going to start with a basic one, which is who am I? So everyone's able to follow along. Essentially, when you're in the shell, it comes with what they call tab completion. So if you type the first few letters of something that you want and then you hit tab a couple of times, it will pop up with commands that match what you've put in. So in this instance, I just put in WH, and there's all these commands starting with WH. If I put WHO, then there's only 3. But I can basically find the command that I want if you can't remember the spelling exactly. And we just put in who am I and then hit enter, and it's going to tell me what my username is. So for everyone following along, if you run this command, you should see your username here, which will be this bit at the just before the @ symbol echoed back to you. Not sure I follow Abdul Salam. So this, okay. So because ARCHER2 is a really big machine with a lot of different nodes, we'll talk about nodes tomorrow, but essentially there are a large number of computers connected together that make up the ARCHER2 machine. It means that there are a very large number of users, and when you connect to ARCHER2, it takes you to one of many landing nodes, and a landing node is somewhere where you can add files, you can move files around, you can do some little testing to make sure that your programs are running. It's where you submit jobs to the bigger cluster. But because there's so many users, it's not a good idea to put all the users on the same landing node. So there are multiple landing nodes, all named LN0 something. So as Juan said, there's 4 login nodes, 1, 2, 3, and 4. And I happen to have been assigned login node 3, but Abdul Salam is on login node 4. And some of you might have ended up on login nodes 1 or 2. So it's not critical which login node you ended up on. That's just an allocation that is provided to you by the ARCHER2 service managing the load of users across the various resources that it had. But good question. Another command that's quite useful is sometimes we want to know where we are on the file system. And the way you find out where you are is you do print working directory. So this is pwd, print working directory. And this just shows you the current location of where you are. On Linux, this slash right here at the front is basically the root directory. So this is the very top directory location. You can think of that as being like my computer on Windows. And then you have some folders underneath that. So you have home, and then under that you have another folder called TO050, which is obviously our project for this workshop. And then under that, for some reason, we have the project again and your username. So you should all currently see something like this with your username tagged at the back. And this is actually called your home directory. So this is your space to add things and to work on this particular login node. If you want to see what's in your folder, you can use the ls command. ls means just list. I think it's short for list. And this will return a list of everything that exists in your current working directory. So if you do pwd, this is where you are, and then ls tells you what's in the directory, pwd. Some of you might not have anything in here at the moment, in which case this would be empty, but that's okay. You can see here I've got a few bits and pieces that I've added for the purposes of testing the workshop material. If you're following along in the documentation, I'm currently on this page, O2 navigation. So this is the navigation moving around and looking things chapter. And I've just hit the first exercise where you scroll down to just below ls, and there's a hidden solution. And this talks about differences between the remote and local system. So for example, here I'm obviously logged into ARCHER2. If I go back to my local shell, so we know I'm local shell because I'm logged into my computer locally here, not logged into Archer anymore. On Mac and Linux, you can use the same Pwd and Ls commands. Windows doesn't give you the same commands, unfortunately, in the command prompt. So if we tried, this is the command prompt, if we tried here to run ls, for example, it'll just tell us that it's not recognized. So the equivalent of ls on command prompt is dir. It just lists all the files that I have here in my home directory. Don't think pwd works either. No. But essentially, if you list those files, you can see that I can see here that this is my local computer because there are all the files that I'm working on in my home directory. So feel free to try that. If you open two terminals or shells, one that is logged into Archer and one that is local, and you can see the difference between the two directory structures and see where you are. Okay. Hopefully there's no questions about that. The next command we're going to learn about is called makedir, which is short for make a directory, and the way that is spelled is mkdir. And this command essentially allows you to create a new directory in the current location. So in the example they use makedir documents, but I already have the documents folder, so I'm just going to remove that. But here we can do makedir documents, and this will just create a folder documents. So now if we do ls, you can see that we have the documents folder. We could create another folder called, I don't know, test folder, for example. You can see that test folder isn't here in the list before, but if we list again after making that folder, we can see that we got test folder here. So the command is mkdir, mkdir. I did tab completion up here because I was being lazy, and there's too many make commands. Yep, thanks, Juan. Okay, so we created a folder. Out of interest, let's see what happens if we try to create a folder again. So we get an error now. Mkdir tells us that the file or the folder already exists. Okay, so Mkdir won't allow us to overwrite information or folders that we already have, and it will throw an error when it finds something that has the same name. Cool. The next section is a little bit about navigation. So we're going to learn about the cd command. So this is just cd, and this allows us to enter or navigate the file system. So we know we created a folder called documents, so we can type that in. And in fact, tab completion also works on paths. So if you just typed in doc and then hit tab, you'll get something like this. So it will find folders. And if you create a similar folder, so let's just create a folder called document rather than documents. And if we do cd doc tab, it will find the first match. And if you hit tab twice again, it will show you matches to that in your shell, and then return a new prompt where you can put in what you want. So we're going to cd into documents. How do you go back to the home directory? Okay, so if you always want to return home, you can use this tilde mark. So this will always take you back to the home directory. And you can check that by doing pwd. If you want to go up a folder, which we're going to get to next. So here I've just entered the document folder rather than documents. So if I run pwd, you can now see I'm in the document folder of the home path. And if we want to return back up a folder, you can use the double dot. So this returns us up one level. So when we run pwd, we can see that I'm back in the home directory. And actually you can keep going up, so we can go up to the project level. And if I hit ls here, we can see the usernames, which are basically all the home folders for everyone else who is following along with us today in this workshop. You shouldn't be able to modify anything that's in someone else's project directory unless they give you permissions. So I'm just going to go back into my directory, and then you can see I'm back here. Yeah, so I created two folders in here, one called document and one called documents. If you try documents, you probably find that that folder exists, so you can go into that folder. Remember, you can always type ls. Oops, sorry. If you're in your home folder, you can always type ls here. You can see what files or folders are available to you in the current directory that your terminal is in. Cool. Any questions about CD or makedir or the double dot or the home directory? Okay, you might just, ooh, ls gives you nothing. I might have to hand you off to Juan, Abdul Salam, sorry. Does anyone else have any questions about CD or Pwd or makedir or some of those commands that we've just tried? Do you want to see anything else again? Nope. Okay, let's keep moving on. You can also use CD to go to complete paths rather than relative paths. So, for example, if I type in documents here, this is a relative path because I'm going from where I am to somewhere relative to my current directory. We can also put in absolute paths or complete paths. So we know that the root file system starts with a / like this. And we know there's a home directory under that, and then there's a project directory and another project directory, and then I know my username exists in there. So we can specify a complete path, and this will take us to that. In fact, if I just specified /home here, in ls, we can see all the different projects that exist within that /home directory. So you can reference different absolute paths using that method. Remember that if you use the up key, you can get previous commands, which is always quite useful. The Linux file system is a little bit different to what you might be used to on Windows, and Mac uses a similar file system to Linux, but it's often obscured by Apple's own programs and processes, so you're not really familiar with what is going on under the hood. If you go to the root directory, so this is just cd/ and type ls, I'll just clear this, type ls, then you'll see a whole heap of folders related to different system settings and functionality on the Linux system. So under Linux, everything to do with the OS is kind of managed through files and different locations on the root directory. So you have things like bin, where binary executables are kept. You have etc, where system settings are kept. You have the home directory, for example, where we were keeping our files. And then you have a whole heap of other folders dedicated to different functions on Linux, including installing user software, optional packages, and so forth. The main ones you'll need to be worried about when using Archer are the home and the work directory. So home is essentially where we've been, and work is where you'll need to put things if you want them to be accessed by nodes for work. And we'll cover that tomorrow, but those are the two important folders. Everything else essentially should be impossible to change. So you shouldn't have any permissions, for example, to, although you can go in and look, you shouldn't be able to create a folder in here, for example. So if I try to make I don't know, test folder. See, it'll give you this permission denied. So you don't have permissions, or I don't have permissions, but no one should have permissions to modify these critical system folders. So don't worry too much about them. Remember that you'll be working in /home or /work. Those are the two places where users need to do things. It may be different on different clusters. So remember that this setting or this setup is specific to ARCHER2. And different clusters might manage how they distribute information or data to the work nodes differently. However, there will always be a /home. Okay. Anything else here? All right. So let's go back to the home directory. So remember, we can go cd / will take us back to the home directory, and we can check where we are with pwd. Good. So we're here. Now, a lot of the commands that I've shown you have what we call flags or options that you can pass to them to get different types of output. These flags modify the programs that are being run to return slightly varied results or filtered options, or modify the program to basically give you what you need. ls, for example, gave us a list of all the files and folders that it could see. But ls has a number of flags. One of those is -a, and flags are always specified with this dash or dash afterwards. And the -a command is good because it lists additional files that are hidden. So files that have a dot in front of them are hidden from ls by default. These are often configuration files or kind of settings files, sometimes that you might need to modify. So for example, we can see we've got our .ssh folder in here as well. So -a allows us to see those hidden files starting with a dot. We can also modify the way files are printed. So the -l option, for example, gives us a listing rather than a table of files, and it also gives us a ton more additional information. So this column tells us about the permissions. We'll cover that in a little bit. It tells us who owns the folder. So this is the username, and then this is what's called the Linux group. So this is the group that the folder belongs to. It tells us the size, and it also tells us the modification date and time, and then the file name. Notice that the folders just have this generic 4096. This is actually the block size. So folders, you can't get the size of the contents of a folder with the ls-l command. There's other ways to do that. We can also chain flags together. So let's say we want to see all the hidden files as well as get that list view. So remember, that was -l space -a. So now all those dot files are also shared with us in this table. And in fact, you can pass multiple flags together. So Linux understands, for example, what ls-la means, because that is equivalent to ls-l space -a. So this ls-la is the two flags together, giving us the same thing. If you see commands on the internet, if you're looking for how to do something and it tells you how to do this, remember that you can break this command down. And in fact, let me just share my desktop here. There is a useful website called sorry, let me wait, no, that's not the one. Oh yeah, explainshell.com. So I'll just put that in the chat for you. If you see a command on the internet or someone sends you a command and you want to know what it does, so we can put in ls-a-l. So this tells us that do not ignore entry starting with dot, right? So that's doing what we thought, and it says use a long listing format. And in fact, this will also work if we put ls-al, and you see that gives us the same thing. And we can do this for other commands. So I think if we put in cd-tilde, so this is change the working directory, and the tilde is, no, it's not working, but this is the argument essentially. So explainshell.com can be useful for understanding commands. All right, let's go back to where we were at. Interestingly, we can also pass indirect or absolute paths to programs like ls. So for example, if we have ls-la, we could pass it the documents folder, and it would tell us the contents of documents, which is actually nothing. So remember, this dot means the current location, and double dot means the parent location. If we were to, so I'm just going to create a text file in documents, the file, and redid that again. We can see that we now see the contents of that file. Well, not the contents, but we see the existence of that file within the documents folder. And you can do this for any location on the computer. So we could, for example, see the contents of /home. It then gives us all the projects, or /work. Again, all the projects, because every project gets its own kind of location to store things under work. All right, some key things, where to go for help. So we saw explainshell.com, that was useful. Most of the commands that come on the bash command prompt or within the shell have a manual page. And the manual page is accessed by typing man and then the command that you want to understand. So let's look at the list command. Oh, apparently we don't have, oh yeah, here we go. Just took a while. So man page looks like this, and you can scroll up and down using your arrows. It gives you a pretty consistent view of what the command does and how it should be called. So the first section here is the name. That's just the command itself. Then it gives you the call performer or syntax. So remember, this is ls, and then the options. So we were passing -L and -A or -LA, and then you can give it a file, or actually you can give it multiple files. That's what this ... means. You can give it multiple arguments. And then below that, it will give you a description of all the flags that are available. If you have a dash and then a letter, these are flags that can be concatenated into a single flag. If you have a dash and then a word, usually, these are commands that cannot be concatenated. So you could call -A and A, but you couldn't do -A author, for example. And there's a large number of flags, which we don't have time to go through, unfortunately. But you can see all the various things LS is able to investigate for you when you're trying to find out about interesting aspects of the file system. The most common way that I use LS is ls-lath. So we do the list. We want to see the hidden files. We want to sort by time modified. So that T there is by time modified. And the H is human readable. So this makes the file sizes a bit more legible. For example, you can see that those file sizes were changed to be in megabytes rather than in bytes. The T also means that we've sorted the time. So you can see here that the most recently modified folders end up at the top, and then most recently modified files are below that, and the last modified files are down the bottom. You can reverse that list by adding an R. So this will reverse it. Oops, sorry guys.
Yeah, 11 is the fire alarm test. So
Sorry,
that's why Tony is.
I forgot that was coming. Yeah. Hopefully everyone's okay. Tried to mute as quickly as I could. All right, so that's the ls command. You also, so remember, to get the manual, we're using the man command, and then anything else we want to try. So we could do man pwd, for example. Oh, that one doesn't have one. Might be too simple. Make there. I think make there has a, no? Yeah, make there has one. Here we go. So make there has a number of options that you can pass to it, for example, which I'm not going to go through, but feel free to type man in any command you want, and you can kind of explore what things are available. All these man pages are also available on the internet. So if you search like manual and any command in Google, you will usually be able to find a HTML rendering of this command. So you don't have to constantly go backwards and forwards between man, what does this command do, and doing stuff in the terminal. You could also open a second shell to ARCHER2, so you don't have to do everything in one shell. So you can see here I'm logged in on shell 1, and then if I go and log in on another shell, then hopefully this works. Maybe not. There's something up with that shell. Anyway, we'll go back to that. No. Okay. There is one last way that you can access the manual page quickly if you just need to do a quick scroll to remember what a command is, and that is pretty much every command comes with this --help flag. If you pass --help to a command, it will exclusively print you the help menu. You then have to kind of scroll back up through that entire printout to find the things that you're interested in. So, for example, we were using the A, the H, human readable, the T, sort by modification time, and what else were we using? L, which was the long listing format. But obviously there's a lot of other things here. Oh, and we also did little r, which was reverse the order. Cool. All right. One last thing is what happens if you pass an option that's not supported. So -J is not a valid flag for ls, and it will just tell you that you passed an invalid option, and it suggests that you go to the help menu to find what you're looking for. So this doesn't mean that the program is broken, it just means it's been invoked incorrectly, and you'll need to investigate the help or do some Googling to find out what actually you wanted to do. Cool. When were we meant to finish this? Oh, this is meant to be a 15-minute job, this one. So we might have to skip the exercises and move on to the next lesson, but feel free to have a go at those exercises during lunchtime. Are there any questions before I move on to the next episode before lunch? Okay, so no questions at the moment, so I'm going to move on to the next part of the course, which is writing and reading files. This should take us up to lunchtime, and then we'll have a 2-hour break after that and come back this afternoon to finish the rest of the workshop. Just a reminder, if you have any questions, feel free to raise them in the chat, and I'll try to answer them as we go. It's always better. If someone is a bit lost, I'm sure there are other people out there who are struggling as well, so we all benefit from improving my explanations of what's going on. All right. Okay. So we've seen how to create a directory, and we've seen how to navigate around. The next step is essentially going to be creating and editing text files whilst we're logged into ARCHER2. So the way we're going to do that to begin with is we're going to go to our home directory, which is the tilde, remember, and we'll just check where we are. So I'm in my home directory, and then I want to create a new folder using makedir, and I'm just going to call it HPC test. So hopefully you're following along in the documentation, just in the first kind of exercise section. And then I want to go into that folder. So I'm going to go cd HPC test, and I'm just going to hit ls, so we can see there's nothing in it. It's an empty folder. Great. Now there's a few different ways to create files. If we want to create and edit a text file, we need to use what's called a text editor, or like a shell text editor. And there's a number of different text editors available. You might have heard of VI or Vim and Emacs, but the simplest one I think that most people should get started with is called Nano. And this is just another command that we call on the command prompt, and then we want to give it a file name. So let's give it a file name called draft .txt. So I'm giving it the extension .txt, which means that this file, to me, is a text file. But you should be aware that Linux doesn't actually care what the file extension is. It considers this whole string here to be the file name. And that file can be any type of file. It could be a binary file, it could be a text file, it could be an application, it could be a folder, and it basically determines what you can do with that file by the program you use to open or access it. The file extension is really just a helper for us so that as users we understand what type of file it is that we're looking at. I could, for example, just call this file draft and try and remember that it's a text file. But the easiest thing to do is to add a useful extension, either .text or .ascii, or sometimes you might get a data file which is also text, but you know that it's got a data table in it rather than just text. Anyway, moving on. So if you execute that command by hitting enter, you'll essentially get a change prompt. And Nano is quite good because it gives you a list of commands down the bottom, and it gives you an editing space. This little hat at the start of each command here means control. So to use any of these commands, you have to press control and then the key that is kind of specified with it. So for example, if I want to do get help, I can press control and then the G key, and then this will show me the manual or the help text for Nano. And it comes with a whole heap of additional information about commands that you can enter with the keyboard or with function keys to basically complete tasks or enter text within the Nano text file editor. So this is basically a text file editor that is rendering in the shell, so we can add text to our file. In the example, they have this text. It's not, so we can just start typing now to add this text to our file. Hit enter. It's not going to run another command. It's just going to go to the next line, which is good. So there's the text from the example. So I've entered my text, and then I need to save my output to the file that I, oh, sorry, doesn't really matter, but let's be pedantic. We need to save our text to a file, and the command to save to a file here is write out. So this allows us to save. You're on a Mac, and it will either be, oh, you can't use command or control. Juan, you have a Mac. Do you know what the correct key is for working with Nano?
That's a good question. I don't know. You try controls. It seems that for other users, control works.
Okay, if they're not working, you could try pressing F1 to get the help menu. Oh, sorry, I didn't say this, but to exit the help, you press Q, which takes you back to Nano, essentially. Okay, cool. That might be something we'll have to investigate over lunchtime. It's not something I've experienced before. So to write out, essentially we need to use the Control-O command. So if we press Control-O or write current buffer is F3 as well. Then we're going to get a new prompt down the bottom here. So you can see things have changed a little bit. We've got a file name to write. So this was the file that we opened, draft.txt, but we could change that if we wanted to. And all we need to do now is press enter, and it will tell us that it wrote 3 lines to the file. Cool. So that is writing a new text file. We can exit Nano and go back to our shell by hitting Control X. And you see this returns us to the shell. And actually, if we rerun the command nano-draft.txt, it will open the file that we just wrote. So here we can see that we've still got those text lines that we added previously. There's a couple of other interesting things that you can do in Nano. It's a relatively lightweight editor, so it doesn't have a lot of the functionality that you might be used to if you're programming in like Jupyter or VS Code or any of those other IDEs. But things you can do, for example, are you can uncut a line. So if you do Control U, Control K will cut a line, so that will remove a line, and if you then Control U, you can put it back. There are options to replace, so if you do Control /, you could find the words perish and replace that with capital perish, for example. So we can do similar things like replace all, or just hit Y here. So this little section here in the front tells you what keys you need to press to perform the action that it's asking. So in this instance, we hit Y, and now we can see that that small p has been replaced with a big P. What else can we do? If you've got a really big file, the go-to line might be useful. So that's Control _ we got Control _ so we could enter that we want to go to line 3, and it will take us there. So this was line 3. If we had a file that was maybe 1,000 lines, we wanted to go to line 500, we could instantly skip forward to that point. You can also use, so this M here I think stands for Shift. So Shift W, Alt W. So M is Alt. So we could do Alt W, where is, so we could look for search right. Oh, right, so that will look for the next version of a word. So let's say I put AND in here. I put my cursor in the AND, and then I hit Alt W. Where is next? Obviously, don't use that command very often. Oh, repeat the last search. Right. So that would be Control W, search for AND, and that one, and then Alt W, and the next one of those. It repeats that search, so you don't have to put it back in again. There's obviously a lot of text editing that you might need to do to set up your command scripts or your batch scripts, which you submit to the cluster. And we'll be using Nano tomorrow basically to set these scripts up. Fortunately, they're not too long, and hopefully any programming that you're doing is on your laptop first before migrating to the cluster. I am not going to cover Vim today, but if you're familiar with Vim, feel free to use that as your text editor. Okay, so remember Control Q exits out of Nano. Let's go back to the shell and talk a little bit about reading files. There is a command so Abdul Salam, you can use Control G to see the full manual list of commands. So there is a command in Linux called cat, which is short for concatenate, and it essentially takes the input of a text file and prints it to the screen. So if we go cat and then add our text file, we will get the output of that text file printed directly to our terminal. Cat can take multiple arguments, so we could also, for example, pass the file twice, and it will concatenate those two files together and print them out. So we get the two files printed at the same time. It might not sound particularly useful when trying to look at the same file, but if you have multiple files, it could be useful to see the output of multiple files. And we'll also see this afternoon how you can use this to kind of join multiple text files together into a single file. All right, I'm going to skip the section where we create multiple text files in the interests of finishing up before lunchtime. And I'm going to move on to the section titled Moving, Renaming, and Copying Files. So there's three commands, or three different commands. Actually, sorry. So to move, rename, and copy files, you can use one of two commands. The first one we're going to learn about is called move, but it's just for short typed in MV. So this is the move command. And we can move, I missed a bit, so we're going to make another directory in here called files. And if we do ls, we can see that we've got our draft.txt and a files folder. And we can use move to move the text file that we created into the folder files. The way we do that is we specify the move command with the text file or the file that we want to move, and then the destination, in this case, the files folder. If we run this and hit ls, we'll see that our draft.txt no longer exists in this directory that we're working in. However, if we move into the files folder, we run ls again, we can see that we've got draft.txt here. We can return to the parent folder, HPC test, if we've decided that we don't want the file in files anymore. We can move it from files. So we'll go move files, and then we know our file draft.txt exists in there. hit tab completion there, right? So I could get the spelling right. And then we want to put it in the current directory, and the current directory is always just dot. So we can move that file back into our current location. If we hit ls again, we're back to where we started. So now we have draft.txt and a folder called files. We can also change the name of the file if we didn't like it. So let's move draft.txt. So this is how we rename files. And in this example, we're going to call it new name.test file. So this is the source, and this is the destination. And because we've specified a file name rather than a folder, it will rename that file. Hit ls again. You can see that our draft.txt is gone, and it now is new name.test file. Just make sure that it has everything that we expect in it. So we're going to use cat to print out the contents of that file, and we can see that it's the same as what we had in draft.txt. Cool. Am I going too fast? Is everyone happy with where we're at? Cool. All right. I've already talked a little bit about how file extensions are arbitrary, so I'm going to skip over that section, but feel free to ask questions about that during the lunch break. But I will talk about the cp command. So sometimes we don't want to just move or rename a file, we want to create a copy of it. Let's say we've created a script to submit our work to the cluster, and we need to edit it to be slightly different, or to reference a different program, or have different settings. And it might be easier just to take a script that we already had and edit that. But we don't want to lose the work that we had previously. So to do that, we're going to use the copy command. And copy is just written CP. Linux people like to abbreviate because obviously you're typing into the shell quite a lot. So the less characters you have to type, the better. So that's why we have ls instead of list, CP instead of copy, and MV instead of move. But they all do what they say on the box. And for copy, we can reference a source file, in this case the file that we had before, and we can reference a location that we want to copy it to. So this is a new file name that we want to copy to. And that will just create a copy. So now if we have a look in our folder, you can see that we've still got our old file, new name.test file, but we have a new file, copy.test file. And again, we can have a look in that file and see what's in it. And it's exactly the same as what we had in new name.test file. And actually, we can do our cat now and see that these two things are exactly the same. To remove a file, we have the Rm command. So Rm is short for remove, and it has quite a few options, but essentially it only works in basic sense on files. It won't work on folders. That's an important distinction that we'll talk about in a second. To remove a file, we can just specify one or more file names in the current directory. So remember, we've got copy test file and new name.test file. So we could remove our copy just by typing rm copy.test file, check what's in our directory, and our copy is gone. Let's create that copy again. And let's also create a copy with with our original file name so that with 3 copies, same thing. But I just want to show you that you can specify multiple file names to this remove command if you want to. So we can remove new name.test file and copy.test file at the same time. Ls, we can see that we've just left with draft.txt and our files folder. What happens if we want to remove the files directory? All right, so we can't remove the file because that doesn't exist. We can't remove files because it's a directory. So rm won't work on directories. We can, however, add the -r command. So -r here stands for recursive, which will remove files as a directory, right? So files is gone. If we remake the files directory, so we're just using makedir to remake it. So now we've got our files again. And I'm going to copy draft back into files here. So funny thing about copy, if you specify a different directory and then you just use the dot, it will create a copy that has the same file name as the source. So that's a useful shortcut. However, what I wanted to show you was if we now try to remove the files directory, which has a file in it, we can still do that. That shouldn't. I thought it was going to throw an error there because it should have. cd files. You know what? Let's have a look at the help here because I thought. Oh, so -r will remove the contents recursively, including what's in the directory. So having that -r there allowed us to remove things. There's another command here which is available. So there's this Rmd command, and this is specifically for removing directories. But what it will do is it will not allow you to remove directories that are not empty. So if you're trying to use rmd, then you have to make sure that your directory is empty before you remove anything. So we could remove, for example, that file from the directory that we copied in, and then we can use rmd to remove that directory safely. So now, because it's not empty, because it is empty, we're able to use rmd. There's a pretty important distinction here between the two. So sometimes people will use a command which looks like this, rmdisrf. This basically means remove all files and directories recursively and do it forcibly. So the F there essentially is like telling the operating system to ignore errors or warnings associated with removing that information. This will still honor permissions, so you won't be able to delete system information, but if you run this command, because you'll see it on the internet quite a bit, you run the risk of removing pretty much everything from your user directory or whatever you specify after this. For example, specifying dot would remove everything from within the current location, and specifying / would remove your user account and potentially damage the operating system. So you need to be relatively careful and think about the commands that you're running when you're using RM, and particularly rm-rf. There's a nice little story there in the documentation about a command that used rm-rf by Steam's Linux client. Steam is the an application or a developer that releases some software that users can download computer games with.